If I have a single random variable x and I define a new random variable z as a function of x, then we have a very nice formula for figuring out the expected value of z. The expected value of z is the sum over all possible outcome of the x random variable, g of xi times f of xi, where f is the probability mass function. That is the formula if x is a discrete random variable. If x is a continuous random variable, then the expected value of z becomes an integral instead, g of x, f of x dx. This is really nice because I don't need to do the work figuring out the entire probability mass function or probability density function of the z random variable. In probability theory, it's just as common to define a random variable z not as a function of a single random variable, but as a function of several random variables. So we will extend the formula for the expected value to the case when we have a function of several random variables. So let's begin with the discrete case and the case when z is a function of two random variables. So x and y are two discrete random variables. Let n denote the number of possible outcome of x. So its range is from x1 through xn. Similarly, the range of y is from y1 through ym. X and y have a joint probability mass function f of x, y, and I defined a third random variable z, which is a function of x and y for some arbitrary function g. Then we have the following result for the expected value of z. So it becomes a double sum where I need to sum I from 1 to n being the number of possible outcome for x. I need to sum j from 1 to m, the number of possible outcome for y. And what I'm summing is g of xi yj multiplied by the joint PMF. So this formula for the expected value of z may look a little bit more complex than it actually is. I think a simple example will illustrate how to find the expected value of z. In this example, the range of x is 2, n equal to 2, and the range of y is 2. So m is equal to 2 as well. The table tells me the value of the joint PMF for all 4 possible cases. My g function in this example is simply a product of x and y, so z is defined as x times y. All I have to do to find the expected value of z is to loop through all 4 possible cases. So I need to go I from 1 to 2, j from 1 to 2. This is my g function. G of xi, yj just becomes the product in this example. And this is the value of my probability mass function whose values are given in this table. So just loop through. In the first term, I is 1 and j is 1. So this is my x1 times my y1. And this is the probability mass function for 1, 1, this number. Next step, I equal to 1, j equal to 2. x1 times y2 times f of x1, y2. y2 is 2, so that's this value. Then we move on to I equal to 2, go back to j equal to 1, and I equal to j equal to 2. Sum all these numbers and you will get 1.4, which is the expected value of this product x times y. There is, of course, an alternative to this method. I could instead find the entire probability mass function of z, and once I know the PMF of z, I can calculate its expected value. So let's move on to the expected value of a function of 2 continuous random variables. So now I want to extend this case to the case when z is determined by a function of x and y. The result is that the integral will become a double integral. So x and y are 2 continuous random variables. The joint PDF is the f function, and the g function determines my new random variable z. Then I can find the expected value of z from this double integral. I integrate y from minus infinity to infinity. I integrate x from minus infinity to infinity. And the integrand is the product of the g and the f function. An example of this, my PDF is given by 4xy, range of x 0, 1, range of y 0, 1, and z is the product x times y. So this is my g function. G of xy is simply xy. I integrate y, since the range of y is from 0 to 1, it's enough to do the first integral from 0 to 1. In the same way, it's enough to do the second integral for x equal to 0 to 1. This is my g of xy. This is my f of xy. If you don't feel like calculating such a double integral by hand, you can use Maple or any other software that does analysis. So just click the double integral and fill out the numbers. So I filled out the limits, my g function, my f function, and I can find the expected value of z, and that comes out to be 4/9.